Namaskar friends. Today we are again back with a new video lecture, and the lecture today is about amino acids. As you know, amino acids are the basic units of which polypeptides or proteins are made up of. So in today's lecture, we'll be specifically dealing about the 20 standard amino acids that exists, and we'll be mainly focusing on how to write the structure of those amino acids. And we will, meanwhile, while studying the structures of the amino acid, will also be trying to classify the amino acids. So let us see what is the basic structure, a general structure of amino acids. So the general structure of amino acid is take a carbon, and as you are well aware, the carbon has a valency of 4. Just put 4 bonds, and these 4 valencies are to be satisfied by groups of atoms. What are they? This side is carboxyl group, CO minus. This side is amino group, NH3 plus. Okay. In the charged state in the body, it is represented as NH3 plus. Normally, it is NH2, but when it is in the charged state, it is represented NH3 plus. This side is hydrogen, and on this side we have some alkyl group. R stands for alkyl group. R stands for alkyl group. So this is the general structure of an amino acid. This is the general structure of an amino acid. What is the general structure of an amino acid? The general structure of an amino acid consists of this C, and to this C 4 bonds are there, and on one side is carboxyl group, on the other side is amino group, on one side is hydrogen atom, and one side is alkyl group. R stands for alkyl. R stands for alkyl group. Okay, this is carboxyl group. You already know. This is amino group. Amino group. Okay. Since this is the carbon, this is the carbon from which we number, generally this carbon is called alpha carbon. Then subsequent carbon, if it is attached there, then they will be called beta carbon, and so on. So to the alpha carbon, we see amino group, carboxyl group, hydrogen are attached. This is the general structure of amino acid. And one very important thing is that the amino acid, we have the 2 forms of amino acid, D and L forms. D and L forms, these are the absolute configuration. Absolute configuration of amino acid. D and L forms, capital D and capital L. You should remember this is capital D and capital N. And most of the amino acids are in the L form. L form, the most common form of amino acid is in the L form. So, how do you know that it is L or D? This L and D forms are based on the structure of glyceraldehyde. On the hand, here you add CHO group, aldehyde. You know aldehyde structure, CHO. This is what? HOH, and this is HHOH. You fill 1, 2, 3. You know that means CH2OH. CH2OH. Now you see in glyceraldehyde, according to convention, if OH is on the right side, it is called D-glyceraldehyde. D-glyceraldehyde. If the glyceraldehyde, again you draw the structure of glyceraldehyde, and if OH is on the left side, by convention it is called L-glyceraldehyde. L-glyceraldehyde. So you see, this is by convention that the L-amino acid and D amino acids will be based on the convention, according to the convention of Emil Fischer, that if we follow glyceraldehyde, we follow the structure of glyceraldehyde. In glyceraldehyde, since OH is on this side, right side, we call D glyceraldehyde, and if OH is on the left side, we call L glyceraldehyde. Similarly, for amino acid, minus, this side is H, and this side is NH3 plus. Okay? And here is R, say some amino acid, whatever is this. So if amino group is on the left side, we will call D amino acid, L amino acid, L amino acid. And the same amino acid, say here, NH amino group is on the right side, and H is here, R is here, and COO minus is like this. This will be called as D amino acid. D amino acid. So you have two forms. On the right, it is D. As OH was on the left, then it was L. If OH was on the right, it was D. So this is the convention, and this convention actually was given by Emil Fischer. Emil Fischer. Okay. Now you already know that what are groups? Those amino acids where R groups are non-polar. Non-polar R groups will be there. Non-polar R groups will be there, and aliphatic non-polar aliphatic R groups. Non-polar aliphatic. Probably this means that they are the R group generally is hydrophobic in nature, mainly hydrophobic in nature, and the R groups are non-polar. So what are those amino acids that R groups are non-polar and aliphatic? For example, here the first amino acid in this group will be called glycine. Glycine. Very simple. You write the structure. How will you write the structure of glycine? Simply write here CO minus. This side you write H. This side you write amino group. And this side, instead of R, you write down H. So when instead of R you write down H, this becomes glycine. This becomes glycine. So we have 3-letter symbol or 1-letter symbol for glycine. So glycine is written as GLY, like this, 3-letter symbol, or simply you can write here G for glycine. So this is the structure of glycine. Now if I ask you one question, what is that question? Is this glycine optically active? That means, does it have a chiral center? Is this having chiral center? No, because how do you define an optically active compound or a chiral center? A chiral center means the 4 atoms must be, or groups of atoms attached to the carbon must be different. So here same hydrogen is attached to the carbon. That's why this is not okay. Glycine is the only glycine is the only amino acid which is not optically active. Why it is not optically active? Because there is no chiral center here. Why there is no chiral center here? Because the four atoms or groups of atoms attached to the carbon should be different in order to have a chiral center. There is no chiral center because these two hydrogen atoms are the same. So this was the alanine. How do you write the structure of alanine? Again, reduce everything C. Write down here C. Here you write down CO minus. Here you write down H. Here you write down NH3 plus. And instead of R, here you write down, you add one CH3. There is one carbon and put the value, satisfy the valency by adding 1, 2, 3. So this is CH3. So instead of R, when we attach the R with the CH3, this becomes alanine. So alanine, symbol 3-word letter is ALA, or simply you can write alanine as A. Simply you write alanine as A. Now, if I ask you, is alanine optically active? Yes, because chiral center is present here. This is called chiral center. And you see, to this carbon, this side carboxyl group is attached, this side amino group is attached, this side methyl group is attached, this side hydrogen. When four valencies of the carbon are being satisfied, the four different atoms or groups of atoms, that becomes the chiral carbon, and hence alanine is optically active. It is optically active. What do you mean by optically active? It can rotate the plane polarized light. It can rotate the plane polarized light. Okay. Valine. How will you write the structure of valine? You see, valine is written as V. So it will be very easy. I will show you how to write the structure of valine. Just you put here C. This side you have to put CO minus. This side you have to put H. This side you have to put NH3 plus. And this side you can write here C. Okay. And then how do you write V? One C here, one C here. This is the just rule of thumb. Like this. You see, I have written here V. Now you can satisfy the valency of carbon. 1, 2, 3. So here you will write one more hydrogen. This will become 4. Here 1, 2, 3, 4. Here 1, 2, 3, 4. So what do you see? What do you see? Can you write this? It's very simple form, or I will write a condensed form of it. How will you write condensed form? C, CO minus, H, NH3 plus, and this can be written as CH, CH3, CH3. In most of the books you will see the structure of L-valine as like this. So you see the valine, how many chiral centers are present in valine? This one is one chiral center, and here this one. What do you see? This one, 1, 2. Is this chiral? No. Why? Because here hydrogen is attached on one side. On one side is attached this one, and on this carbon, both the same things are. So only one chiral centers are present in the alanine. Okay. So this is alanine. So this is valine. This is valine. The structure is branch chain. And how will you remember the structure of valine? Very easy. Just the basic structure of amino acid is one side carboxyl group, another side is amino group, another side is hydrogen. And on R group, you have to write the V-like structure like this. And on all the points, you write down carbon. And then you satisfy the valency of carbon. So here one hydrogen will be there. So 1, 2, 3, 4. Here 1, 2, 3, 4. Here 1, 2, 3, 4. So you condense from CH3, CH3, CH, CH, CH3, CH3. Now you know how to write the structure of valine. Leucine. How will you write the structure of leucine? You see, in valine, You just have to do what? So first you know the basic structure, okay? CO minus, this side is NH3 plus, this side is H, and here in heading, what did you see? You saw one and then branching. You left side two carbon and then give branching. Okay? In heading, you put just one carbon and then branching. Here you put two carbons and then do branching. And then satisfy the valency. 1, 2, 3, 4. 1, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. See, this is not just a class of amino acid. This is about how to write the structure of amino acid. This is very important. People don't understand what is written. How will I memorize the structure of, say, some amino acid? So it is very easy now for you that in valine there was one carbon and then branching. You have added two carbon then branching. So how will you write the condensed formula for this? CH, NH, 3 plus, CO minus, and then go for it. CH2, then CH2, then go for here CH, and then go here CH3, CH3, and then here CH.